Yeah, welcome to today's class, and today we are going to be treating the second topic in JAMB physics syllabus, which is scalar and vector. Now let's go. A scalar quantity is a quantity that has magnitude but no direction. So scalar quantity has magnitude but no direction, while a vector quantity has both magnitude and direction. So we have to know that vector has both magnitude and direction, while scalar has only magnitude but no direction. So now let's look at some common example of scalar and vector quantity. So you have to know some of these things. In fact, it's even advisable to know all of them. So now let's look at example of scalar quantity. We have the mass, time, temperature, volume, density, speed, distance, energy, power, pressure. While vector quantity, we have displacement, velocity, acceleration, and the rest like that. So you can pause the video and look at this table. It is very important for you to note it very well. Now let me now move forward to the concept of relative velocity. So when we talk about relative velocity, is the velocity of one body with respect to another body. The velocity of one body with respect to another body. And something about relative velocity that you should know, that if two objects are moving in the same direction, then the relative velocity is the difference between them. That is if they are moving in the same direction. Why if they are moving in opposite direction, the relative velocity is the sum of the magnitude. Now let's look at the first example here. A car A move 20 meters per second east. Car B move at 12 meters per second east. Now if you now look at both of these car A and B, you will see that they are moving in the same direction. Car A and B are moving in the same direction, and because of that, we are going to subtract from both of them. We are going to subtract 20 minus 12. So the relative velocity of A with respect to B is 8 meters per second east. So now let's look at the second example. A man walks 1.5 meters per second towards the front of a moving train. It walks toward the front of a moving train. So we minus 1.5 minus 25, which will give us this. The reason why it is negative because it is moving towards the rear of the train. Now let's now look at a very important aspect too, that there is a distance between there's a difference between distance and displacement. So distance is a scalar quantity, while displacement is a vector quantity. So you can look at the total path length, shortest distance to the end. Distance has no direction since it is a scalar quantity, while displacement has direction. Now, resolution of vector. Any vector can be broken down into two perpendicular components. So we have the vertical component and the horizontal component. So if you want to resolve vector to the horizontal component, we use cos, r cos theta. While if you want to resolve it to the vertical component, we use sine. And this is the formula for us to find the magnitude of resultant vector. And this is the formula to find the direction. I will still show us an example as we start. Let's just look at all these first. This will serve as a foundation to the question that we are going to be doing next. Now let's look at this example. A man walks 4 meters east. So a man walks 4 meters east. He walks 4 meters east, and then 3 meters north, and then 4 meters west, and then 3 meters south. So the total distance is 14 meters, but the displacement is 0 since the man is going back to the starting point. So you have to know that too. Now, if you want to know about resultant vector and resolution of vector, you have to know about the concept of parallelogram law of forces, and I have made a video concerning that already, so I will put the link in the comment section. So it is important for you to go back to that video to understand how to resolve how to find the resultant of two vectors. If they are at right angle to each other, we use the Pythagoras theorem, but if they are inclined at an angle with each other, we use what we call the parallelogram law of forces. So click on that link to learn more on parallelogram law of forces. And now let's look at this question here. I want to teach you on resolution of two or more vector. So we have 4 vector here. We have 10 Newton, 12 Newton, 5 Newton, and 9 Newton. Now, there's something that we must know. In the horizontal component, the left will be negative, while the right will be positive. So that means that if you are resolving all these vectors in the horizontal, this 12 here, when we are doing for the horizontal component, it will be negative. That's because it's on the left side. I hope you understand. While for the vertical component, those that are up will be positive, while the one that is down will be negative. So when we are doing for the vertical component, 9 Newton and 15 Newton, they are going to be negative. I hope you understand that one. So I first wrote all the forces down, the 9 Newton, 10 Newton, 12 and 15, and I have to find the angle inclined to the horizontal. So you have to be very careful. There are some questions that they will draw the diagram, but the diagram, the angle is to the vertical, but you have to find the angle inclined to the horizontal. So let's look at 9 Newton. 9 Newton is going like this. It is going straight downward, and the angle inclined to the horizontal is 90 degree. While for 10 is straightforward, is 30 degree. For 12 is 40 degree. While for 15 Newton it is 60 degree. It is straightforward. And I have already mentioned that when we are resolving to the horizontal component, we use cos. While we are resolving to the vertical component, we use sine. So when I slot in this value, the angle 9 cos this, so this is what I get when I sum all of them together. And look at the vertical component too. When I solve the all of them together, this is what I got. And please, if you need more lecture on this, you can send a message to my WhatsApp number. There is a class going on about JAMB physics lesson, so be a partaker of it. Just message me. It's just a token. The money is not much at all, so quickly message me. There are a lot of things that we still need to understand concerning the resolution of vector. So now to find the resultant vector, it is square root of x squared, that's the horizontal component, plus y squared, that's the vertical component. I slot in the values here, and this is the answer that I got, 11.60 Newton. That's the result. Our resultant. Now for the direction, so I use this formula, arc tan y over x. That's the vertical component over horizontal component, and this is the answer that I got. So now let's now move forward. We will now be doing some question concerning what we have learned. So now, which of the following is a vector quantity? We have speed, mass, displacement, and temperature. So we should know that displacement is a vector quantity. Now, number 2, a physical quantity that has both magnitude and direction is called vector. So vector is a physical quantity that has both magnitude and direction. Now, number 3, which of the following pairs contain only scalar quantity? So force and velocity, no, that's not the answer. And the reason why that is not the answer is because velocity is a vector quantity. It cannot be acceleration and weight. Acceleration is a vector quantity. It cannot be momentum and power. Momentum is a vector quantity. So the answer here is B. Now let's now look further to relative velocity. Two cars are moving in the same direction. Car A move 30 meters per second and car B move 18 meters per second. So since they are moving in the same direction, we just do 30 minus 18. So 30 minus 18 is 12. So the relative velocity of A with respect to B is 12. It's as simple as that. Now, let's look at this one. A man walked forward inside of a moving train. Moving inside of a moving train, moving at 20 meters per second in the same direction. So the velocity related to the ground will be what? The answer here is 20 plus 2. 20 plus 2. So the answer to this one is B. Now let's look at this one. Two objects move towards each other. They move towards each other at 15 meters per second and 25 meters per second respectively. Their relative velocity will be what? So now let me do. So one is moving like this and the other one is moving like this. So 15 meters per second, so we have for 15 and then we have for 25. Now the relative velocity between them will be 15 minus 25, and 15 minus 25 is 10. Now let's look at number 7. When a vector is resolved into two perpendicular components, the horizontal component is cos. I've already said that when we are resolving to the horizontal component, we use cos. Now look at this question. Number 8. A force of 5 Newton act 30 degrees to the horizontal. So the vertical component will be r sine 30. R sine 30. So that will just be 50 times sine 30. 50 times sine 30. And 50 times sine 30 is B. So the answer to this question here is B. And if you need the PDF, this PDF I can actually send it to you. Just ask for it in the comment section and I will send you the link in which you will download it. Now let's look at number 9. The parallelogram method is used to find, okay, the answer is B. We use it to find the resultant. Now look at number 10. Two forces of 8 Newton and 6 Newton, they are right angle to each other. So I've already said that when two forces are perpendicular to each other and want to find the resultant, we make use of the Pythagoras theorem. I hope you understand. So this will be the resultant. So if this is 8 Newton here, this will also be 8 Newton and then this will be 6. So we make use of Pythagoras theorem. So 8 square plus 6 square. 8 square is 64, 6 square is 36, and that is 100. So the square root of 100 is 10. So the answer here is B. Now, number 11. The direction of resultant vector is found using, the answer is C. You can check the note above to get that answer. Number 12. Distance is always a vector quantity. The distance is not vector quantity. Greater than or equal to displacement. Yes, distance is usually greater than or sometimes equal to the displacement. Distance cannot be less than this displacement. The distance cannot be less than displacement. Now let's look at number 13. A boy walk 5 meters east and then 12 meters north. So we are now asked to find the displacement from the starting point. So this is 5 and then this is 12. So we use the Pythagoras theorem to find this one. So that will just be 12 square plus 5 square. So 12 times 12 will be 144. So 144 plus 25. And that will give us 169. And the square root of 169 is B. So the answer here is B. Now number 14. After walking a square field and returning to the starting point, the displacement will be equals to 0. Displacement is equal to 0. So which of the following is not a vector quantity? Position, displacement, distance. So distance is not a vector quantity. So number 16. Okay, in a coordinate system, we should find the distance from the origin point. So let me show you the question. So we have our x-axis is +3 and our y-axis will be -4. So we should find the distance from the starting point. So this will be it. So this will be 3 and then this will be 4. So we just make use of Pythagoras theorem, 3 square plus 4 square, and that is 25. So the root of 25 is 5. So the answer here is B. Now number 17. A frame of reference in which Newton's first law for hold is. The answer is C. The Newton's first law is also called the law of inertia. So I think we are going to stop here for today. And if you need any more assistance about this, you can send a message to me. Thank you and have a wonderful day.